Hello and welcome to CS61A CSM week 6 question number 1. So here we are doing what would Python display along with drawing box and pointer diagrams. So before we start, I want to emphasize a few concepts. The first one is the idea of shallow copying. So when we are slicing a list, we are creating a new list. So we won't be mutating the current list, but instead creating a completely new object. However, the pointers in this new list will point to the same objects as the pointers in the original list. So when we look at this example here, we can see that A is equal to the list with 2 elements, 1 and the list 2, 3. And in this box and pointer diagram, the first element is 1 and the second element has a pointer to the list 2, 3. Now we set B equal to the sliced version of list A. And here we can see that a completely new object has been created with B a pointer to this new list with 1. But the second element points to the same object that list A was pointing to. So this is really important to remember because you might be tempted to draw out a new pointer with the list 2, 3. However, you have to remember that because of this idea of shallow copying, the objects in the original list that were pointed to will also be pointed to by the new list that we create after we slice the list. Okay, so the second important thing to remember is that these two are very, very similar. However, if you see this with plus equals, then elements, this will mutate the list. So these elements will be directly added to our list. However, when we have list is equal to list plus elements, so these are slightly different, this will create a completely new list. So our list here will be a pointer to a completely new list with new elements added to it. All right, so now let's start the problems. So the first problem says A is equal to 1, 2, 3. So here, let's draw a box and pointer diagram with A being a pointer to the list 1, 2, 3. And what will A return? A will return the list 1, 2, 3. Next, we have A index 2. So in this case, this is index 0, 1, and 2. So A index 2 will return the this element, which is the number 3. So we return 3 here. Next, we have A index negative 1. So when we have a negative number as the index, we start from the back of the list. Since this is negative 1, negative 1, negative 2, and so on, negative 1 would again be this element right here. That's 3. Okay, now we introduce a new variable B, and B is going to be equal to A. So here, B will be a pointer that points to the same object as A points to. Now here's what we just talked about. A is equal to A plus and this list right here. So A, this creates a completely new list. So A, instead of pointing to this list, will now point to this new list that we'll be creating. So let's draw this new list. That'll be 1, 2, 3, which is the same as the previous A. Then 4. And then we have this 5, 6 list inside of this entire list, which makes this a nested list. So our last element will be a pointer to this list, which is 5 and 6. And now this doesn't point to this, but instead this new list. Okay, then we return A. So that would be 1, 2, 3, 4, 5, 6. When we return B, that would be this right here. So we will be returning the list 1, 2, 3. All right, now we are introducing a new variable again, and this time it is C. So C, it points to whatever A is pointing to. So let's go ahead and point that to here. And now A is set to the list 4, 5. So again, the pointer to A now becomes a pointer to this list. What does A return? A returns 4, 5. And C returns this. That is the same thing as this. So 1, 2, 3, 4, 5, 6. Okay. Now we have the next page. So let me just copy this box and pointer diagram that we created and add it here. Okay. So now we have variable D. And here's where we can see this slicing. So D, and we want to slice C from index 3 to index 5. Remember when we do list slicing, we do not include the second number. So the first number 3 is included and the second number 5 is excluded, which means that we want, so what does C point to? C points to this list. We want 0, 1, 2, 3, 4. We want these two elements to be in our new list D. So let's set D to a new list that has this sliced 4. Sorry, that's really okay. 4. Then remember the concept of shallow copying. So this second element right here will point to this. All right. Next, we have C index 3 is equal to 9. So we will just be replacing this current index 3. So again, this is 0, 1, 2, 3. And we want to change that to 9. Now we are returning D. So D is this, we just created D. So D would be 4, then 5, and 6. All right, next we're getting the index of an index. So first we will be going into C index 4, which was this nested list 5, 6 right here. Then we will be going into index 0 of that nested list. So index 0 of that nested list is 5, and we want to set that equal to 7. Now we want to return D. And because of the shallow copying idea, this changing of element in C has also changed an element for D. So D would be 4, 7, 6. Okay, next we have C index 4 is equal to 10. So this time we want to completely change this C index 4 to 10. So this pointer will not be here anymore because we are not referencing this list of 7, 6 as the fourth element of the element of index 4. We want to change this to 10. And D, when we want to return D, D has not changed at all. So it'll be the same thing as above where it's 4, 7, 6. Now finally, we want to return C, which is what we just changed. 1, 2, 3, 9, 10.